Hey guys, welcome back. So here I have created my authentication service, and so I just want to go ahead and talk more about it. First things first, we are using Redis for our authentication service. All right, right over here. This is just Redis Insight. It's just a way of seeing it through a GUI platform or GUI. Um, and anyways, the reason why we need this Redis platform, I'll explain it in a little bit, but it's basically to store the sessions because we are using session-based authentication. Now, a cool thing about the how I configured Redis was I actually configured it to be in the Redis clusters. All right, so Redis has something called Redis cluster. This is very, very good documentation on how to set it up in a development environment, and then in production environments, you can also set it up through like a virtual server, which runs on Linux, and then follow these instructions, or you can use a fully managed system, which will scale it and do everything for you, like Elasticache or Azure has one too, I believe. But that's, anyways, this is the documentation, all right? You just search up Redis clusters, will be the first thing. And essentially, what it allows you to do is it allows you to horizontally scale. All right, it allows you to horizontally scale your Redis database. Now, within a database, if you guys didn't know, by the way, I should give some context. If you guys didn't know what horizontal scaling means, is it's like this. All right, I like visualizing it because it will help you understand it better. So horizontal scaling, visualization. Sorry, images. All right, there we go. So this Geeks for Geeks image is really, really good. It perfectly depicts it. So you have two ways of scaling your application. All right. And what do I mean by scaling? Well, when you publish your app to the broader audience, right? It's obviously going to gain attraction. I mean, that's the hope, right? And as your app gains these users and this attraction gets more hits with the API, right? Gets more server requests and people start visiting it more often, the server or the hardware that you use is going to get overwhelmed. All right. It's going to eventually reach a breaking point where your server and your app will start becoming unreliable and it'll start breaking down, right? So to combat that, we need to have some scaling practices in place, right? That's what scaling means, right? You're going to scale your app out to more users, right? So there's two ways of doing this. There's horizontal scaling and then there's vertical scaling. So I'll talk about vertical scaling first because it's the easiest out of the two. And vertical scaling simply means you're going to have one server. Okay, so one server, one piece of hardware is going to run your whole app. All your users are going to be directed to that specific server. But what's different is every time your server starts getting overwhelmed, you're just going to upgrade your hardware. All right, and that's why you kind of see them getting bigger. The size is to signify that they're becoming more powerful in terms of the hardware. This way, they're able to handle more users. But eventually, it will reach a point where hopefully your app has succeeded so much that the highest hardware specs that you can get through vertical scaling are not enough. Okay, and you need another way. Additionally, vertical scaling can be very, very costly because of the fact that hardware is very, very expensive, right? To upgrade your hardware, it's super expensive. So that's the two reasons why people sort of shift away from vertical scaling, and many companies, especially big ones, they use horizontal scaling instead. And horizontal scaling goes about scaling in a different way. So what's going to happen is instead of, upgrading the hardware, you're going to have the same hardware in terms of the server, right? But what's different is the amount of load coming to that server, or the amount of request coming to that server. It's not going to be the same as the vertical scaling server, and that's because of the fact that you're going to have multiple instances or multiple servers running. And then you're going to have something called a load balancer. Essentially, what a load balancer is it allows your user to be redirected to a specific server which doesn't have that much load. okay, or which does not using that much of the hardware, right? And so essentially what we're doing is as soon as we start, and you could configure this through auto scaling, but as soon as one server starts getting too many requests and starts getting overwhelmed, another server spins up as well. All right, so now you have two different servers in which they both can take a request because both are identical. They have the same code, same operating system, everything's the same, right? So what's going to happen is with this load balancer, which again just distributes the traffic to these different servers, it will just pick which server to redirect the user's request to, depending, all right, depending on whichever server is not that overwhelmed. So in the case of this being newly started, right, and this server being there for a long time, logic states that this has to be the one that's overwhelmed, right? Because again, the whole reason why we spinned up this server was because this server could not handle any more requests. So what would the load balancer do? With any other new incoming request, instead of sending it to this server, which will break and it will become very, very, very slow, it will send it to this server. All right, and this server is fresh. It's basically new. It doesn't have that much request, right? It's a hardware. It's not being used that much, so it'll be very, very fast. All right. Now, with this method, you can just keep scaling out to have multiple and multiple servers, and you'll never reach a bottleneck, right? Whereas in this case, you will eventually reach, in vertical scaling, I should say, in that case, you will eventually reach a point where you cannot upgrade your hardware more longer. And if you do not implement horizontal scaling, then that server will struggle and eventually break and crack, right? Whereas over here, you're just going to have multiple servers running, and that way, you can just keep adding more servers as you scale and you get more users, right? And that load balancer will always be there to distribute the traffic based on which server does not have that much request and which server is not that overwhelmed. Additionally, another very cool thing about horizontal scaling is that it also provides a fail safety. What do I mean by this? Well, with vertical scaling, you only have one server, right? So if that server goes down, you're done. That's it. The server's gone. You can't do anything about it, right? Because you relied on that whole server to host all of your traffic, right? Whereas with horizontal scaling, if one or let's say even two servers fail, you still have another server to rely on. So at worst, maybe your request, that server, sorry, becomes a little more overwhelmed, right? So that's how I recommend just using horizontal scaling, because it's just much more better in terms of scalability and with fail safety as well, as I just mentioned. All right. Anyways, that was just like a quick understanding into horizontal scaling and vertical scaling, and why horizontal scaling is preferred in industry rather than vertical scaling. So how does that tie back to the Redis clusters? Well, the Redis clusters is actually going to be implementing horizontal scaling. But now the issue is that a Redis is a database or storage system. How can you implement horizontal scaling on a database solution, right? Because remember, you're spinning up multiple instances. In a database, right, you're going to have all your data within one server, right? One place, right? So then how can you spin up multiple instances and still have the right request that you get from the user go to the proper database, right? Because again, you're going to have just multiple copies of the same database, so eventually it'll become very inefficient, because if you have just multiple copies of your database and then a user creates a write request, you have to send that write request to each database. So to combat this, what Redis clusters does is it uses horizontal sharding. All right. And this is how horizontal sharding works. So it works exactly like horizontal scaling. You're going to have multiple instances, right, which are called shards in this case. But essentially what's happening is each shard or database or instance, right, all mean the same thing. But anyways, each shard will have a portion of your database. So instead of having a one big collection which has all of your data, right? And that means that we're pretty much forced to use vertical scaling, or we could use horizontal scaling, but then we would have to have multiple reads and writes to different to each different server, causing inefficiency, right? So in order to combat those two issues with both scaling methods, with horizontal sharding, you're adding just a portion of that data within each shard, and that's based on a specific field. In the case of Redis, you have a key pair value, right? Key value pair, I should say. So you have a key, and then you have a value that represents that key, right? So what it does in Redis clusters is they take the key and they use a complex algorithm which they have, and they hash it, and that hash gives us a number. All right, and then once we get this number, each shard has a specific range of data, or sorry, I should say hash. So each shard has a specific amount or range of hash, in which you can store it with. So for example, let's say shard 1, right? Shard 1 would have a limit from 0 to 1,000 shards. Sorry, hashes, right? Then shard 2 would have it from 1,001 to 2,000. So now let's say you make a write request, right? What's going to happen is Redis is going to hash the key that you give it. And let's say when they hash that key, you get the number 100. So that means you're going to go to shard 1 because that is the range within what shard 1 has, right? Shard 1 is 0 to 1,000. But then let's say in another request, you make a write, and in this case, it is, let's say the key is like blue, and that when you run it around this hashing algorithm, that gives you 2,000 on the dot. In that case, you're going to go to shard 2 instead, because that's the range that is met, right? It's from 1,001 to 2,000. So that means that you would save it in shard 2. All right. Now, same thing with read requests. So when a read request comes in for a key, based on the hash of that key, it will go to the respective range, right? So anyways, that is horizontal sharding. And then we also talked about the scaling as well. And that's what I'm doing with my Redis clusters. All right. So that's how I'm able to handle multiple and many requests, which I expect because I'm using sessions. All right. And sessions are going to be highly requested. All right. And that's another reason why I'm using Redis. And I'll get into all of that later on. But all you need to know is this horizontal sharding method, and then horizontal scaling, and then Redis clusters to actually implement that horizontal sharding, is how I'm able to scale my Redis database very efficiently. All right, now that we understand that a little bit more, let's actually see this in action. So if I go into my terminal, all right, you'll see that I'm already connected and I have different shards, right, which are running on specific ports. So these literally represent these different, these different instances. That's what they represent, right? So if I go back into Redis CLI over here, what I can do is I can go ahead and make a name. All right, so let's set a name of Hemet, for example. Now you can see in this case, it says okay, and I can go ahead and get that name and I get Hemet. All right. In this case, we're not being redirected, right? Because remember, we're on 7004, which is actually a shard. We're connected to a shard currently, which is 7004. All right. Now, let's say I set an email of Hemet V. Patel. All right. In this case, it's also going to be saved in 7004. All right. Because you can see that's not giving me a redirection message. Let me go ahead and set something else. Let's set A to Hemet. See, in this case, you will see that it's being stored in a different shard. In this case, it's being stored in this shard. All right. This one over here. Okay. And that's because the hash of A is different or not within the range of 7004. So that means that we literally got redirected to 7003 and then we set it over there. So now if I try to get name now, it will redirect me back to 7004 because again that is in a different hash slot, which is not in the range of the 7003 shard. And we still get it, right? We still get the name, but again, it's not in the same shard, so it's just redirecting us. And this is all happening with Redis clusters, right? I'm not doing anything, all right? All I need to make sure is that when I connect, right, I add the -c command. So that means that cluster mode is enabled. If I don't, I'm going to get a moved error when I try to get get a key value pair which is not within the shard that I connected with. In this case, 7001. Right, as you can see, I get an error of moved because it's trying to go to 7004 because that's where it is, right? That's where the data is, but the cluster mode is not enabled, so Redis gets confused. Okay, now that we've seen that in real life, again, just follow the documentation and it'll teach you how to do everything to the T. I'll also link a YouTube video down below, which really helped me, and that's how I set up everything within a development environment, of course. Let's go ahead and look at session-based authentication within a visualization. So I can just go ahead and explain how everything works. All right. I like using this because it really shows the request. So let's go ahead and use this. All right, perfect. So what's going to happen is the browser is going to go ahead and post a request to a login endpoint. All right. And I'm going to show you that with my app. But anyways, in that, you're going to have your body, which contains whatever credentials you need to verify. All right. Then that is posted to the server itself. Okay. Now, once it's posted into the server is going to go ahead and verify those credentials that you gave it against a database, probably. All right. Now, this database is probably not going to be Redis because Redis can only really store key value pairs. The only reason why I use Redis for sessions, and we'll kind of see where that ties in with this whole architecture, is because it's very, very fast. And for for sessions, it's fine if we use Redis because you're not going to really store that much complex data within it. But anyways, without all the app, again, you're gonna post from the browser to the server. The server has now verified against a database that, okay, this user, the password was correct, the username was correct. So now what's going to happen, all right, is the server will go ahead and assign a session to your user. It'll go ahead and assign a session within a specific persistent storage database. All right. Now, in this case, it's telling us to store it within in-server memory. I wouldn't recommend that. That would lead to scalability issues because you're storing everything within your the server that's running your Node.js app, and you don't really want to do that because it will lead to performance issues going on. So instead, what we'll do is we will store it in an in-memory database, but instead we'll store it in an external in-memory database instead of using the server that hosts the Node.js server. And in that case, the perfect candidate would be Redis, because Redis does exactly that. It's an in-memory database, and that the whole reason what in-memory even means is that means it will perform very, very fast. And what we're doing is we're just going to be storing the session within Redis. All right. Now we store that session within Redis, and then we're going to send a cookie back to the browser. Okay. We're going to send the cookie back to the browser, a cookie. Now, what's so special about a cookie? First of all, cookie is persistent within a local environment. In this case, our browser. So it will be able to store a key value pair. In this case, it's going to be the session ID, which will reference back to the server later on. And basically, the reason why we use cookies is, again, it will be able to be persistently stored. But additionally, on top of that, it will also be able to be attached to a next request that you make within that backend server. So whenever you send another request now, you're going to have this cookie of session ID that is already attached with it. All right. This is much more better than, for example, storing it in local storage, because yes, local storage will store your data persistently. So even though when you refresh it, it will still be there for you. It will still do all of that, but it will not attach it with the next request that you make with the specific backend server. But with cookies, you can do that, right? It will automatically attach it with new requests that you make with that backend server, so you don't need to do any other further configurations. So, anyways, you set the server will send that a cookie back with the session ID. So now the browser, whenever we send another request that needs to be authenticated, right? We're gonna go ahead and automatically send that cookie, which has a session ID, because again, that's the behavior of a cookie. Then once it goes to the server will reference it to the in-memory database. In this case, I'm using Redis. It doesn't have to be in memory too, by the way. I know I'm saying in memory, but it doesn't have to be. It could be any database, just has to be persistent. Um, but anyways, we're gonna go ahead and send that request. It's gonna double check on Redis because that's what we're using. And then if it's able to find a session with the specific session ID that you sent with your cookie, it will go ahead and authenticate you, say you're good to go, and give you your response back. All right, so now that we've gone through the theoretics of everything and we kind of learned how session-based authentication works, what horizontal sharding is, what horizontal scaling and vertical scaling is, and then how we can implement that with a database solution efficiently through horizontal sharding, let's go ahead and actually see this in action through these couple of endpoints that I've created within my app. All right. Now this app is highly scalable. Everything's very well done, and this code will be available on GitHub later on. But anyways, over here, all right, I'm gonna use. I've already registered my account. All right. As you can see over here, through Postico. So I'm gonna go ahead and create a new account. All right, so we can do all of this again. All right, because this was just when I was like double checking everything, testing everything out. So I'm just gonna use a new account over here. I'm gonna use docker.hemit@gmail.com. These are all different emails that I have created, just so that I can. So let me just copy this. Just for development purposes. All right. So register will not assign a session. All right. It's just going to register within the database. So it will save it within the database. All right. I'm going to keep the password and the name the same thing. So if we send this, it will give us a user has registered successfully. And if I look within my Postico, which is just a GUI app that allows us to see our local or production SQL servers, specifically Postgres. So it gives us a visual way of going about developing. And that's why I really like it. But anyways, because of that, I can actually see my user collection over here. So if I go ahead and refresh, you will see that a new record was made over here with Hemit Vimo Patel, a hash password, because that is the production level of doing things. So that way it is completely masked. Your password is completely encrypted and safe. And then you also have a docker.hemit@gmail.com. This is the email that we just registered. And in this case, the is verified is false. And that's because we have not verified if this email even exists. Because you can verify a email's pattern, right, by having your username and then and then a domain, right? You can verify the format in which you have an email, but you cannot verify if that email is actually true. But there is a way of doing it, which is through sending a verification code to that email using a cloud based email provider, right, which will automatically send those emails for you. In this case, I'm using SendGrid, which is a Twilio product. So the way that we can do that is through generate code. So we're gonna go ahead and give the email that we use, docker.hemit@gmail.com, and then the type is going to be verifier, right? Because we want to verify our email. Then all we have to do is press send. It goes ahead and says token is sent to the user. Now, if we look in our email inbox, you will see that it automatically sends me a brand new email over here, which says your verify code. Uses this very, very nice, CSS code that I have made, this HTML template, I should say, and I have my code over here. So I'm going to go ahead and copy this code. And this code is being stored within Redis as well, actually. So if I refresh this, you will see a verify, and then the string has my name in it, or my email, I should say, and then my code over here. And you'll also see over here, it says 4 minutes. And what this means, what this 4 minutes means actually, sorry, I did not mean for that. But anyways, what this 4 minutes means is that it's going to, this key value pair will be expired within 5 minutes actually. But it just says 4 minutes because it doesn't count the 1 minute from before. But within 5 minutes, this key value pair will be deleted from the Redis database. So that means it will become invalid within 5 minutes, which is just a security feature. So that people cannot guess it, right? Because you only have 5 minutes. And additionally, I also have implemented rate limiting. I've talked about this with my other tutorials, which severely slow down the brute force attack. And paired with this 5 minutes is basically impenetrable, unless you get a very, very lucky first guess. Anyways, we generated that code. We got that code. So now, how do we go ahead and verify ourselves? Well, we're going to use the verify endpoint with /auth. Everything is /auth because, that's how I've set it up with my controllers and my routes. But we don't need the new password right now. We will need our code, which is this. And then we're going to also need the email, which is docker.hemit@gmail.com. There we go. Let's go ahead and hit send. As you can see, user email has been verified. They may log in now. So let's go. We've verified that this email is actually true and exists. This is just to prevent, trolls and people like that who just are masked behind a fake email address that can't really be tied back to them. But this way we know that the email is real and valid. Anyways, when we refresh this, you shall see that now it's a true. All right, and this is just a Boolean value, right? But anyways, you can see is verified is now indeed true. And this means that we can actually go ahead and log in. All right, and I'm just going to put in docker.hemit@gmail.com. Again, dogs are cool is actually a wrong password. So if I go ahead and hit send, it will actually tell you that invalid email or password. And this just shows you the practical way of the first flow that we have over here, right? In which we're posting from our login route endpoint. In this case, it's auth/login for me, which has the body with all my credentials, all right? And what's happening is within the server, it's going to cross-reference to the database. The database will tell it if it exists or not, or if the password is wrong or whatever. And based off of that, it makes a decision. Do I make a session or do I say, hey, this is wrong? In this case, it says, hey, this is wrong, right? Because again, it's not dogs are cool 1, 2, 3, it's cats are cool 1, 2, 3. All right, so then it just gives us this error, right? Tells us 401 unauthorized, which is just a code for, this is the wrong password, or, you're not in, you need to try again. Additionally, on top of all of that, if I look in my Redis, right, because again, we talked about this, we're storing it within Redis, our sessions. If I refresh this, first of all, you'll see that my token is gone, and that's supposed to happen even though the 5 minutes haven't been up yet, because I already used that code once. So I don't want that code to be used again within that 5 minutes, right? So as soon as it's used, it's single use. So as soon as it's used, it's gone because we deleted it. But anyways, if I look at this, if I refresh this, you'll see there's no session here. And that's because it's invalid, right? This password. So I'm just going to make this cat circle 1, 2, 3. Go ahead and send this. As you can see, logins are successful. In cookies, I will actually see a cycle ID. So this is the session ID for that, right? Which goes ahead and aligns with this flow as well. Because again, we are first of all storing the session within a database, in this case Redis, and then we are sending a cookie with that session ID back to the browser, right? In this case, it's my Postman test environment. So if I just come back here, that's why we have this over here as a cookie, right? And we set the name as cycle ID within our express session configuration over here. But now if I look in Redis anyways, refresh this, you will see a new collection, which is just this, and that includes our session ID and our different I should say, credentials. In this case, I only gave it the email, as you can see here, which is just docker.hamid@gmail.com, right? So yeah, everything is good to go. As you can see, the session is stored correctly and securely. And now I can go ahead and use my app however I want, because I actually made a middleware which just double checks if the session .user exists, right? Which is where we're storing all of this data. But now let's say, okay, I'm done. I want to log out now. All right. So the way to log out is, first of all, I'm just going to make this none. You could still keep it. It won't really matter. But anyways, keep the body, but you don't really need to, because logout does not really accept anything. But anyways, with auth/logout post, I can go ahead and log out of my environment. And what this does is it's very, very simple. It just deletes the session from your cookies and from your Redis. It doesn't directly delete it over here, because the Postman environment is kind of weird that way. But I can assure you that your cookie is deleted. And to further prove that, if I look over here, you can see that the session is still alive. But when I refresh, you can see the session is gone now. All right. So that's how the logout works, right? We're just deleting the session. Now, another thing that I can do is, I talked about how we can verify, right? But let's say you forgot your password, all right? You forgot your password. So let's say you want to reset your password. So you're still going to use generate code to verify that you are the owner, right? Because you have no way of logging in. So you're going to verify through a code, which is going to be given to you through type reset. I go ahead and run this. The token is sent to your user, as you can see through here. All right. Additionally, what you do is you go to a new endpoint, or you're going to make a new request to reset password, in which you're going to take both of these key value pairs, but you're also going to take new password, which is just going to be whatever you want it to be. In my case, I'm just going to say Hamid Patel. Not a very safe password, by the way. But if I try to run send, you'll see that the code is not valid, and that's because this code is not actually my actual code, right? It's actually this one over here. So I'm going to go ahead and use this one, and I'm going to press send. And as you can see, user has changed their password successfully. It works. But now if I try running this again, you'll see that the code is not valid, because again, this code is a one-time use. And if I go ahead and look in post-eco, just remember TQ at the end, and this way we're just going to cross-reference it with the password when we refresh it, just to prove to you that the password did change. So if I refresh, you can see that the TQ is now replaced with the LM, which proves that this whole password was changed. All right, so that's how all my authentication system works. And yeah, I hope you guys enjoyed this little video.